Today's topic is transformations. Before we talk about what transformations are, we need a little bit of background information. That information is that all functions can be grouped into families based on their general type. For example, we are going to be talking today about the family of linear functions. The linear functions are a family that consists of all the functions whose graphs are lines. The fact that their graphs are lines are what they all have in common. Function families have parents. These parents are called the parent functions, and they're the most basic member of each family. All the other functions in the family are created by causing one or more changes to the parent function. These changes are called transformations, and they are the topic of today's video. Although you can transform any kind of function, we are only going to be transforming the linear functions right now. So the first thing you need to know about the family of linear functions is that its parent function is f of x equals x. You could also think of this as simply y equals x, and this is the most basic line. The thing that is basic about it is that it has a slope of 1, and you can see that both on the graph that it goes up 1 over 1, and also in this little gadget that I have, which I'm going to be using to change the slope, the m is set to 1. The other thing that is basic about it is that its y-intercept is at 0. We usually call that b, my gadget calls it c, but it's the same thing. So you can see that it crosses through the y-axis at 0. Transforming the basic line is going to mean changing the slope and changing the y-intercept, which will make the graph look different. In this video, we're going to look at 3 different changes that we can make to either the slope or the y-intercept to transform the graph. The first type of transformation we're going to look at makes the graph of this line, this basic line, either narrower or wider. And the way that you make this graph narrower or wider is by changing the slope of the line. So the first thing we're going to do is look at what happens when you make the slope bigger. And when I say bigger, I'm talking about in absolute values. So say going from what I have now, which is 1, and increasing it, say to a slope of 2, or a slope of 3, or a slope of 4. And you can see that each time I increase the slope, I am making the graph that we see narrower than it was before. This graph of f of x equals 4x is narrower than the graph of 3x, which is narrower than the graph of 2x, which was narrower than just the graph of x. So, for example, the graph that we had just been looking at, f of x equals 4x, is 4 times narrower than f of x equals x. And that's because we made the slope 4 times bigger. Now, on the flip side, we need to talk about what happens when you make the slope smaller. And first, I want to remember that we're talking about making the slope smaller in absolute value, not making it negative. Because, for example, the graph of f of x equals x and f of x equals negative x are exactly the same width, because they both have as their absolute value a slope of 1. So what I'm really talking about is making the slope smaller in absolute value. So I'm talking about going from, say, a slope of 1 to a slope of 1/2 or 0.5, and then moving from a slope of 0.5 to a slope like 1/3 or about 0.3x. And you can see as I am making the absolute value of this slope smaller, so it's becoming a smaller and smaller decimal, what's happening is that the graph is getting wider. So, for example, the graph of 1/3 x is actually 3 times wider than the graph of f of x equals x. And that's because we made the slope 3 times smaller. 1/3 is 3 times smaller than 1. So what you want to remember here is that bigger slopes make the graph narrower, smaller slopes make the graph wider. Our second transformation is going to be reflecting the graph over the y-axis. Reflecting the graph over the y-axis is going to happen when we change the sign of the slope. So for example, right now I have graphed f of x equals 1.5x. So changing the sign of the slope would mean making this into negative 1.5x. So that's what I'm going to do right now. I'm going to change the slope to negative 1.5. And look what happens. The graph flips over the y-axis. So that's what a reflection means. It still has the same narrower or wideness, but it's flipped the other way. So I'm going to make myself a note that a reflection means being flipped over, kind of like a mirror image. And it works the same way going from negative to positive. So say, for example, that I was looking at the line with a slope of, let's say I started with negative 3. So let's say I took the graph f of x equals negative 3x, and I wanted to reflect it over the y-axis. What I would do is I would change the sign from negative to positive. So that's what I'm going to do right now. Here's negative 3x, and I'm going to change this to just positive 3. And now it looks exactly the same, but it's a mirror image flipped over the y-axis. So here's our example. To reflect over the y-axis, so for an example for your notes, you should write down that to reflect negative 3x over the y-axis, what you would want to do is change that equation to y equals positive 3x. So you're taking this negative and making it positive, and that will cause this reflection every time. Now for our third and final transformation, we're going to be talking about vertical translations. And vertical translations are going to happen when we change the y-intercept. We haven't looked yet at any y-intercept changes. So we're going to start again with the graph of y equals, or f of x equals 1.5x. And what I'm going to do to this graph is I'm going to change the b value. In this case, they're calling it c, but we know we always call it b. So I'm going to increase the y-intercept. So it's going to become 1.5x plus 1, now plus 2, plus 3, plus 4, plus 5, plus 6. Or if I wanted to, I could go back down. I could start moving the graph. Instead of from 0 and going up, I could make the y-intercept negative. So now I'm going down. So what happens when you start changing the y-intercept is that you make the graph move up and down. So a vertical translation is a shift up or down. So a good example that you should pause and write down is that the difference between 1.5x and 1.5x minus 6 is that 1.5x minus 6 is translated 6 units down from the place where just 1.5x was. And the last important thing to know about vertical translations is that you can tell if it's going to be a shift up or a shift down based on the value of the y-intercept. So if you have a y-intercept that is positive, that's going to shift the graph up. And if you have a y-intercept that's negative, like the one that you see here, that's going to shift the graph down. So it's all about whether that b value is positive or negative. So before we finish up, I just want to look at a couple more scenarios to give you a little more experience. My first question is, what is the difference between the graph of f of x equals x and the graph of g of x equals 5x? So if you compare them, you see that the difference is their slopes. G of x has a slope of 5x and f of x has a slope of 1. So what has happened is that the slope is bigger. So that means that g of x must be narrower than f of x. And since it's between 1 and 5, that means that g of x is actually 5 times narrower. My next question is, how would you change the equation of k of x equals negative x to make the graph 3 times wider? So in order to do that, what you would need to do is make the slope 3 times smaller. And for this, you want to ignore the negative because we're only talking about absolute value. So to make the slope 3 times smaller, what we would do is change the slope, and instead of saying negative x, we would say negative 1/3 x. So that's a slope that's 3 times smaller, because smaller slopes make the graph wider. Third question, how would you change the equation of h of x equals 3x minus 1 to reflect it across the y-axis? So that we know that to reflect across the y-axis, we need to make the slope negative. So we would write h of x equals negative 3x plus 1. So if we looked at these two graphs, they would look exactly the same, except they would be mirror images across the y-axis. And last, what is the difference between the graph of f of x equals 2x plus 4 and the graph of g of x equals 2x minus 1? So if you look at them, you see that they do have the same slope, so they're going to have the same narrowness or wideness. But what they don't have the same of is the same y-intercept. So we've got different y-intercepts. And different y-intercepts are going to affect where they're located vertically. So we know that changing the y-intercept causes a vertical translation. So if we go from 4 down to negative 1, that means that we went down 5 units. So g of x is shifted down 5 units from f of x. And with that, we're finished. In the coming days, we'll be looking at many more questions like this about transforming linear functions.